Alright, this is for question number 53 in chapter 4. So I've just written out the names of the cars that they list just to save time. So the first part is asking about which car has the most force acting on it and the smallest force based on its mass and time it takes to get to 60 miles per hour. So the first thing we need to do is figure out the meters per second from the miles per hour. This is very important. I forgot to do this when I first did it. So if we convert this, 1 hour is equal to 3,600 seconds, and there is 1,609 meters per mile. So that gives you 26.8 meters per second. Now we need to understand that acceleration is just the velocity over time, and the force is just mass times acceleration. So we can take the Alfa Romero, for example, and the sum of the forces on that are equal to its mass, which is 895, times the acceleration, which is the velocity, which we have here, divided by the time, which is given in the chart. So that would be 26.8 meters per second divided by the 4.4 seconds it takes to get there, and that gives you 5,451.4 newtons. And you're just going to repeat this same process for all the cars based on their weight and their time to get to the 60 miles per hour, or the 26.8 meters per second. So I'm just going to fill this in. Because it doesn't take much explanation after you know the process. Let's see, this one's 1320 times 26.8 over 6.4. This one is 1435 times 26.8 over 5.4, sorry, 3.9. This one is 1468 over 26.8, or 26.8 over 5.4. This one is 1650 times 26.8 over 7.2. And you get results that give you this. So we can see from here, this one for the Ferrari gives you the largest force, and the Alfa Romero has the smallest force, but the book will give you an answer for the Alfa Romero and the Honda being the smallest, but I'm assuming that they made a rounding, or they rounded it somewhere in there, so it came out close to the same. Now for part B, I'll just write it right here. It's going to be exactly the same. Your acceleration is still going to be exactly the same. The only thing that you're changing is the mass. So instead of these masses that they give you for the car, you're putting in the mass of the person. So since we know that, I'll just put in the calculations for the Alfa Romero, and it just repeats for all the cars. So for the Alfa Romero, it's the 72 kilograms for the person times the 28.6 over 4.4, which gives you 438.5 newtons for that car. So this is the Alpha, or yeah, it just corresponds to this line. So the Honda, that one would be 301.5 newtons. Following the same example, the acceleration is equal to whatever you have for the Honda here. Again, you're just changing the mass between the two. For the Ferrari, you get 494.8 newtons. The Ford, you get 357.3 newtons. And for the Volvo, you get 268 newtons. So the Volvo has the smallest force on the person, and the Ferrari has the largest. Now for the next part, it asks you, let's see, where's C? When the Ferrari accelerates from 0 to 100 in 8.6 seconds, what is the average net force acting on it? How does this net force compare with the average net force during the acceleration from 0 to 60 miles per hour? And explain why these average net forces might differ. So let's do C right here. Yeah, you can see that. Alright, C, same idea like this. We need to convert 100 miles per hour to meters per second. So 1 hour is equal to 3,600 seconds and 16.9 meters per 1 mile, and that gives you 44.7 meters per second. You still have the same mass for the Ferrari. So you have 1435 times the new velocity, 44.7, divided by the time that they give you, which is 8.6 seconds. And that'll give you 7,457.7 newtons. And in the book, they just round that to 7,500 newtons, or 7.5 kilonewtons, I think they wrote. And this differs from this one right here, because it's a smaller force because of the time frame that you have to get to this velocity, and you're dealing with less drag, or sorry, increased drag. So the faster you're going, the more drag you're going to have, and the more vacuum you're going to have behind the car, which is going to bring your force down. And the last part asks about, it's just a conceptual thing. Discuss why a car has a top speed. What is the net force on the Ferrari when it is traveling at top speed, 196 miles per hour? So you have a top speed because at some point your car can't put out more acceleration, because at that point when you're at top speed, the acceleration of the car is equal to the force of drag on it. So if you look at the equation like this, you can have the mass, but once you hit a point where this force is equal to the force of drag, then the acceleration doesn't matter, and it goes to 0 because this force is equal to the force of drag, and that's when you hit your top speed.